And we're live. We're finally back for the VFX Graph Part 2. It's been a while. I've been anticipating this. I'm so excited for this stream. We did the last one in October, I think, Kodran, last October. So
yes, we did.
It's been a long time coming. I'm really excited for this. Today, we will be diving into VFX Graph. We'll be moving particles along splines. We'll be diving into splines in VFX Graph, and then we'll be moving them along SDFs. And then we're going to wrap up the stream by building the BTs, the beach things, from Death Stranding. Along the way, we'll be looking at references, breaking them down, and taking your questions. Make sure if you're joining us, I see a lot of familiar faces in the chat. If you're joining us in the chat and you have any questions, make sure to ask them as we go live. We'll be answering questions as we're building the graphs and looking through things. But before we jump into it, I want to introduce the guest for today. If you don't already know, it's Kodran. Kodran, please introduce yourself.
Yeah, thank you for having me, Hassan. I work for Unity. I'm a software developer / technical artist. For the technical artist side, I do mostly shaders, VFX with VFX Graph, hence why we're doing the today's shows. And I work for a very special team inside of Unity called the Verticals Workshop. So shout out to my team, who's also kindly giving me the time to do these kind of things. So happy to be here.
I'm so happy to have you back. So this is not your first time on stream. This is actually your third time. First time you joined us for VFX Graph. Second time you were with us live at GDC, the big stage. We were diving into enemies, looking at some shader graph stuff at that time, actually.
Yeah.
But today we'll be looking at VFX Graph. So one thing we're going to be doing is breaking down seemingly complex effects, right? Things that you usually see in big budget games, we're gonna make super realistic for just one person to build right now, right?
Yeah, so I mean, I built the samples for this stream alongside a general theme, and the general theme was making dumb things kind of look smart in a way.
Yeah.
And whereas the first episode we dived into more principles of VFX just to see a bit of the building blocks, like the simple ones, this one is a step further. And it's more for art directing your particles. It's more for creating more visually complex particle systems. Mm-hmm. And you'll see that later on when we start building the BTs. It's going to be a lot of fun.
Oh, I can't wait. Usually when you start talking about VFX and building your game and visuals, you usually talk about the 80-20 rule. You've brought that up to me in the past. Can you tell the audience a little bit about that?
Yeah, so it's a general principle that you only need 20% to know 20% of the tools to generate 80% of the output. Mm-hmm. So this is sort of the mantra of how I approach building these samples. I don't want to crowd the stream with a 4 hour long stream with just me tweaking float values from 0.2 to 0.5 in order to make this very specific effect that is so esoteric in nature, that is so precise that people are just not going to use. I'm just going to show you, hey, this is the base plate. Here's how you do it. Here's the principles behind it.
Yeah.
And you take it however far you want it. So this stream is not really about having final polished effects. It's more like taking you to a visual effect that is 60 to 80% of the way there. Mm-hmm. And then that's good enough. Okay, we move on to the next one. Because, it's not a good idea to just keep tweaking values all day long.
Right. Yeah. I love that principle because it's like you can open up a tool like VFX Graph or Shader Graph and then be overwhelmed by all these nodes. There are so many nodes because it allows you to do so many different things, but you don't actually need everything. You need a few things. And we're going to be looking at those few things, some of those few things like today on the stream. So we're just generally looking at like the building blocks that will make up those effects, right? So the BT itself that we'll be making at the end is composed of two different things, right? There's the spline umbilical cord, and then there is this particles moving along the body itself. We'll show some visuals for that soon.
Yeah.
But maybe we should actually show, so there's another trailer you have, something your team actually worked on in the past that shows off splines and SDFs, right?
Yeah, so basically at Unity, we have something called Hack Week, where a bunch of people from multiple teams just get together and just decide to build one project in 1 week. And so I got together along with 8 other people inside of Unity. And we sort of built this audio reactive scene where, with really cool lighting, really cool assets. Again, credit to a lot of other people at Unity Eric, Camille, JP, and my team did an amazing job on the art. But I was doing most of the effects in there. And so a lot of the stuff that you see on screen is a lot of the stuff that we're going to be talking today. So we're going to be talking about splines, we're going to be talking about SDFs, and how to combine them together to sort of create a modern day visual effect that's in a game today, like Death Stranding.
Yeah. Okay, perfect. So let's cut right to that trailer. We're going to fast forward to just about 30 seconds so you can see what we're talking about. So the trailer will play and you'll see a quick fast forward. So let's cut to that trailer. That looks so good. Were you playing the piano there, Kodran?
No, that was not me. Again, I made this with 8 other people. So we luckily had, I mean, this is on screen, you know. And we had some engineers that were doing the auto reactivity. We had some people doing the shaders. We had some people, like I said, doing the 3D assets, the concept art, the lighting too. And really, it's a collaborative effort that was done. We managed to make this in 4 days, which was something I was really proud of, and proud of the team as well.
That was all done in 4 days?
4 days. 4 days.
That's so good. So can you speak to what we're seeing on screen right now and how that's going to apply to what we're doing today?
So so my contribution to this project was the visual effects for it. At least most of it, not the fireball ones at the end, but yeah. So you see this sort of like leaf trail that goes from the right all the way to the center. So that's called that's a spline-driven visual effects, something that we're going to go over today.
Yeah,
and it connects to this ball, this sphere that you see at the center, which has sort of these particles or leaves moving around it in a sphere shape. Yeah. So that's called the Sine Distance Field, also known as SDF, which is a popular technique nowadays in visual effects to get more complicated silhouettes in your VFX. Mm-hmm. Albeit that this is not the most sophisticated shape, it's just a sphere, but we're going to dive into more sophisticated shapes in today's stream.
Okay, cool. I'm excited to see that. And that's going to be like the shape of a human body and a few other things, right?
Yeah, a few other things, yeah.
Awesome. And so we're going to jump right into making splines. But before that, can you just define what a spline is to anybody who's watching who's not aware?
Yeah, so a spline is essentially a curve, or even more simply, a line in space. So typically, splines are kind of ubiquitous in game development. They're used from anywhere, from AI behavior to just like do a sort of a path, like say for like an airborne bird, and you just want it to move along a spline or curve. So you want to art direct where it moves.
Yeah.
Or cameras, for instance. You know, we have an important tool here at Unity for cameras called Cinemachine. Mm-hmm. And that's used to sort of put, dolly cameras on tracks, which are splines. Yeah. And I just want to showcase that splines essentially are available to you the same way that they are for cameras. They're available to, in VFX Graph. And they're sort of this one tool that allows you to get a lot out of some very basic setups. Mm-hmm. Because you can't just be moving your particles all the time in random ways. Sometimes they just have to move in a certain particular direction, do some things at the beginning and maybe morph into like a shape. Similar to my example, this was like a trail of leaves, but it can be like a hurricane or smoke trails. It could be sort of a monster that just has like these curves that just morph into the ball. Right. So yeah, the world is your oyster with this kind of tool. This is just me showing you what the basic building block and a basic setup in VFX Graph to get you rolling with it in case you ever need it. And
we're going to show how fun it can be. I want to cut to, before you explain what you actually made and what we're going to make, I want to cut straight to that B-roll of what we're actually making today.
Yeah.
Let's just give it a moment.
Yeah, so it goes a bit. So yeah, what you're seeing
what did you make, Kojin?
So what you're seeing on screen is actually a food maelstrom. It's a food hurricane. I decided to not take this example too seriously. Yeah. And also, it's a good opportunity to showcase a lot of the cool stuff that's on the asset store. So I used asset store 3D models. This one I think was let me know what it's called. It's called Fast Food Mega Constructor. I just basically used
we'll drop a link to the fast food mega constructor in the chat.
Yeah. And it's just created this like sort of hurricane effect. And obviously, this is just done, in the theme of food, but you can put whatever leaves, you can put smoke trails, you can put like embers to make sort of like a tornado, for instance, or a character assisted VFX where the character is in the middle and it sort of has this smoke enveloping him. And yeah, it's the same principles behind this.
I mean, it's surprisingly beautiful. The colors of the food, they're so saturated and so rich.
Yeah.
When I first saw this, I was like, the first time you sent it to me, I was like, man, that's so gorgeous. What is that? Then I see an egg and then a piece of bacon, a piece of lettuce. I'm like, what is this? Yeah, I know, but it actually looks amazing. So we dropped a link to that asset pack in the actual chat. So this is looking like two splines side by side to make is that what's happening here? Is it actually
it's actually four splines, and they're just pointing in different directions. So they have sort of the spiral.
Okay.
So yeah,
it's just the same effect duplicated.
Exactly. You just switch the assets. That's pretty much it.
Nice. And then I think we're going to also look at some references in order to kind of visualize splines being used in games. So if you want to get creative with it, it's always good to look at other references. What are other games doing? So right now we're looking at, can you guess what game this is in chat as we get to the spline? Who can guess what game this is?
Very iconic.
A very iconic game. Yes, let us know in chat. Come on, first person to guess it gets nothing. Just get, bragging rights.
But yeah, just a quick thing for this one.
Yes, they got it right. Dishonored 2. Dishonored.
Exactly.
Both Nick got it first. Good job.
An amazing game. And honestly, I'm showing you these references because it's good to contextualize what we're doing. Yes. And like I said, splines are ubiquitous across game engines and across the CPU or the GPU and across areas of a game. Yeah. For instance, this might not be done with as a visual effect. It is done as a visual effects, but the back end behind it might be on the CPU or drawing these lines that you see between the heads.
So those lines are the splines, yes? Those are drawn with splines, probably. Yeah.
I don't know if they use splines for it, but a spline could be a method to achieve this kind of effect.
Got it.
And you also see the traversal mechanic, which is basically sort of a curve where they use the power on the left hand to just propel itself towards high ground or low ground.
Yeah.
That's looking like a Bezier curve. Now, I don't know if they use the exactly Bezier curve as a solution, but it could be used as a solution for VFX, is what I'm trying to say.
Simulating like the trajectory of where the jump will take you, right?
Yeah. So it could be like 4 control points, start from the hand, second in the middle, third in the middle, create the curve, and the fourth point is the one that's actually touching the wall. So that creates a nice spline.
There you go. That was it right there.
There you go. Yeah. So Dishonored is one of the examples just to showcase it done as a visual effect.
It can be used for completely different things too, right? So we'll jump to the second reference to show how wide the use case of splines is.
Yes.
So Can you guess what game this is? Let's go, chat. You can. Oh, there you go. There's your spline.
There it is. So yeah, this is Control.
Yes, probably got it.
A gorgeous game, by the way. And this is showcasing Splines as a boss battle. And obviously, this could have been animated frame by frame, but Splines here, I mean, you see it, following a path in a certain way, being animated with the control points and all this stuff.
Yeah.
So this is, I like to believe that this is, a spline-driven a boss. Yeah, this is just to showcase again how universal this technique is, not just for visual effects, but like I said, camera, boss battles, NPCs, AI behavior.
Yeah.
Again, the sky's the limit.
So Fawi got it right, says Control. Everybody else in chat says Among Us for some reason.
Yes.
Absolutely. This is Among Us. You got it.
Among Us, the ray traced 4K version.
Exactly, yeah. But yeah, okay, so I think this would be a great time to cut to your screen, Kodrin, and we can start diving right into how this is done.
Yes. So right now we're in the editor. I'm taking control over it. But this is the effect you were seeing. Yeah. I'm going to show you quickly what it looks like in the scene. So we're just going to do a breakdown in the visual effects to showcase what this simple setup can achieve.
Right.
And first and foremost, I'm just going to disable the post-processing because just to make it clear anyways.
Maybe we can full screen the scene view here.
Yeah. So like I said, this is a simple setup of a spline. And a spline of visual effects graph has 4 control points. So you get the visual effects here, which is, sorry, I'm gonna enlarge the 3D icons. So you get the visual effect icon here, and obviously all the control points are game objects that are being parented under the visual effects. And this is the first control point. So you can see that just by manipulating the control points, you manipulate the curve and where these particles are heading off to.
Yes.
And you can control the endpoint. And similar to how you saw it in that boss, this is what you really need to do to art direct this thing is basically use the control points of the timeline or slap some script in there to add some noise, and you can art direct your particles.
So if you've used like splines in Cinemachine or Bezier curves, maybe in Photoshop or anything else, this should be quite familiar to you.
Yes, very familiar. Absolutely not a lot of difference, to be honest. So yeah, I feel, for this particular sample, I built sort of this very basic setup of like a small food tornado. So this is just the same effect duplicated 4 times and just adjusted for the control points so they move a certain way, and slap the camera on there to make it look pretty from a certain angle. And
add some post-processing.
Yeah, add some post-processing, which is through the global volume here. Again, some depth of field never hurt anyone.
And what render pipeline are we using here?
So today, since we're not trying to polish anything to 100%, not even 90%, we're just using the universal rendering pipeline.
Okay.
And not only that, we're doing everything in unlit mode. So not having any sort of Lambert shading on it or normal maps. We're just using a texture with a model. Obviously, you can push it further if you want it, but that's up to you.
And we have a question from Voxel Tech asking, is this project available for download?
Yes. So towards the end of the stream, we're going to pop in some links. One of the links is going to be to my GitHub, where it's called VFX Essentials. And essentially, I'm going to release these samples on that same repository, minus the asset store stuff, because obviously we have Unity privileges. We can get this stuff for free. But I mean, if you want to buy them, buy them and support the creators. And they're going to be freely available for you to just plug and play and start messing around with it. So the same setups you see here.
That's great. So let's dive into it. How do you get started with these splines?
So let's go back into scene view. We're going to have a side-by-side view here. And we're just going to look at this simple one. Obviously, we're going to go zoom in right up in here. Like I said, I'm assuming some previous knowledge of VFX Graph. I'm assuming that you know what the spawn context is, what the initialized particle context is, what the update particle is, and the output. We're not going to go over that. We're just going to go over how to use splines.
Yeah.
And so in Unity, right now, splines are represented as Bezier curves, and that's one way of representing it. Now, there's all sorts of different functions for representing splines, but for the ones that have it, that we have right now in VFX Graph that's currently supported, it's the Bezier curve.
Right.
And you can access it by just typing sample, and this is the parameters you get. And it comes with a timestamp parameter, so 0 being the start of the curve, and 1 being the end of the curve. Mm-hmm. So whenever you use your particle, you're going to sample this slider to position it along the spline. And you get 4 control points, A, B, C, and D. And these are your 4 control points that you see in the scene right here.
All right.
Now, in this example, you see I connected 1, 2, and 3. These are exposed properties. So exposed properties in Visual FX Graph are properties that you can access from the inspector, which you can see here.
Yes.
So you can see position 1, position 2, position 3.
That makes it a lot easier to quickly change values without diving into the graph all the time, right? Yes. Okay.
And let me just enlarge it a bit for our users. And in Visual Effects, in Visual Effect Graph, right now, the VFX Graph team has a way of just plugging in game objects or the position or property of a game object into the graph itself. And I'm just going to quickly show you like what the setup is here. It's called a VFX property binder. So basically, you add this. It's a script coming with VFX Graph out of the box. You put in your transform, in this case, the P1 per first position. You drag it in there. Mm-hmm. And then you assign it the exposed property value. In this case, it's 1. But you also need to put an underscore position, if depending on what you have. So
right.
It's a position, you put underscore position, and vice versa. But yeah, so that's really the setup here that I just wanted to explain a tiny bit, because it might not be obvious since it's still a new tool.
So we do have a question from chat from Endless Doors asking, can VFX Graph be used in a mobile game?
It depends on the device.
Okay.
So, notoriously, mobile devices had a hard time with compute shader related tasks, and VFX Graph is built on compute shaders. So it really depends on the device that's being ported to. I can't really answer fully that question because there's some things that I don't know. But best thing to do is slap on a VFX, done with VFX Graph, try to port it to mobile and see if it works. That's my best bet.
Yeah, that's great.
And so, yeah, like moving on, the setup here, obviously, I attach the 4 control points to a sample Bezier curve.
Yes.
And the thing that's going to move our splines along its trajectory is the age over lifetime. So age over lifetime is sort of the lifetime of a particle. Right. 0 being it just started, 1 being it's close to its end, it's going to die. Just keep in mind what it's plugged into here. And I'm just going to disable quickly some of these parameters here. For instance, let's just stop the update so it doesn't move.
And so that way you're making sure that the particle is dying at the end of the spline, right? Because you're connecting the particle's life to the length of the spline. Yeah. That's what you just connected right there in the beginning, right?
Yeah. Okay. Also, my bad, I had the wrong graph open, but it's the same one. Yeah, it's just another one that's based on the same one. Cool. So yeah, let me just disable the position so you guys know exactly what's to be expected here. I'm going to set the velocity to random, and we're going to put some of the stuff here. Actually, no. Let me just re-enable the position, because the particles need to be moving, have some kind of motion in order to be represented in space, like this one. Let me just remove a bit of the color. Sorry about this, so you can see them to their full extent. Okay. So now they're fully visible.
Yeah.
And like I said, let's just remove this age over lifetime from the sample Bezier curve. And by the way, the sample Bezier curve is connected, outputs a position at a sample point.
Yes.
So,
that's a great way to visualize it.
Yeah. So you see, you have your curve here, and what you do is, that's what the t value here does. So 0 being the start of the curve, 1 being the end of it.
Got it.
And what the outputs is the position. So that's the position that we set into the update function. So it updates every frame.
Yes.
And obviously, we want each particle to be moving, differently at different speeds. Right now, the setup we have here is, okay, the particles get initialized according to a sphere position, like they spawn as a sphere, which has a different radius. You can move around here. For instance, I could put a bigger radius, and it's going to have like a bigger representation. But yeah, and I set some lifetime random. Each particle has their own lifetime. And as soon as I plug it in,
so those values along the main graph are just those are parameters for the particles itself. So you're putting in the actual mesh there, you're putting in the colors the way you want the mesh rendered, and it's lifetime. Then you're connecting that lifetime to the actual curve.
Yeah, and this is what gives you this this effect here. Now, this is pretty stiff. All right, like you notice it's not moving with the built-in physics system of VFX Graph.
Okay.
It's moving with like a hardcore set position. So
because it's in local space?
No, it has.
No, okay.
So in visual effects, you can move things according to physics, or you can move things according to like computationally strict parameters.
Got it.
So here we're just for showcasing how to use a sample Bezier. We're moving things to strict parameters, so they move strictly along the curve.
Yes.
And obviously, if I added something here to spruce it up to just make it look a bit more random. Obviously, one of the parameters I used was the add some a random angle, and I can disable this here to make you see. Obviously, this is. Angle is just rotation in VFX Graph, so now it looks like just a couple of pills or jelly beans.
Yes, they're all like just taking the exact same angle here.
I'm re-enabling them.
Looks less natural.
A simple setup, just a couple of offsetting values, and I can just multiply it to just make it spin more faster or slower. And then there's the other thing where you see that they're spread out, or they move with some form of jitter in a way. That's because I added some noise here.
Can you zoom in just a bit more on the nodes themselves so that the audience can see it more clearly? Yeah.
So you notice the sample Bezier curve.
Perfect.
Node has the position hooked up to an add node on the position here.
Okay.
And before it's setting it, and you can see that out of the box, it gives you the spline straight up. I mean, as uniform as uniform can get. Yeah. And it's just strictly respecting the shape of the curve. But in VFX Graph, you want to add some variety, and we have noise that can actually contribute to these kind of things. So this is one way. You can get the particle ID, add the position here just to create some more randomness before you put it in the coordinate system of a 3D noise. And then you plug it into the coordinates, it's being sampled, and it gives you some three-dimensional vector. And then you can multiply that to emphasize the spreads or the randomness. And
spread is a value you've put, right? Is it just a float?
Yeah, it's a float. So it's exposed as a parameter here. You can see at the bottom left. And
your face is covering it, but they can imagine.
Okay. Yeah. But let me just put it here so people can check it out. But if I just increase the spreads, you see. Increases randomness, and obviously the noise itself has parameters that you can manipulate, like the frequency, so it moves in different ways. But since I wanted to move in a more smoother fashion, I just put it like 0.1. Obviously, you can increase the amplitude, and these are sort of things that are available to you to just
if there was a crazy hurricane going on, you might increase the noise.
Exactly.
Exactly. Yeah.
So that's the fundamental basis for how to use a spline in VFX Graph. You notice that I didn't talk much about the tangent.
Okay.
So tangent is another parameter that's available to you. So you know how at every position we sample the at every given lifetime of a particle, we sample the position on this Bézier curve. We can also sample the tangent, and the tangent is just the direction that the curve is pointing in at any given point.
Yes.
So you can imagine the curve going like this. Well, the vectors are going to be the ones pointing along that direction where the curve is facing at any given point. And this is a useful parameter for doing things with forces, for physics related stuff, and make them move in sort of different ways. I guess I could like show it a bit.
Love to see an example. Yeah.
Yeah. So let me just add a force parameter here, and just let me just disable the fact that I put some set position. Now it's going to move relatively fast, I guess. Like, I haven't I'm doing this on the fly, but yeah. So you see the particles are moving extraordinarily fast in one direction. That's because there's an accumulation of force in that particular direction.
You can decrease that force.
We can decrease it. We can add a multiply node here. So plug in that multiply node. And obviously you're going to have to decrease it to like a really
you can
small...
hardcode the value, or if you wanted to extract it and expose it, you can add it to your blackboard.
Yeah. But you see now it's moving still in the general direction, but it's curving a bit here. So, it's more physically accurate, but because our particles have such a velocity accumulation, they're just going to still go into that general direction. But I can still move this thing and point it towards different areas, and it's going to influence the force a tiny bit.
So is it taking the tangent from the first point of the curve? Which tangent is it taking?
So the tangent, it takes it. You remember how we visualize that the start of the curve is 0 lifetime and the end of the curve is 1 lifetime.
Mm-hmm.
And as each particle navigates between 0 and 1, it's going to take on 0.1, 0.2, 0.3.
Definitely.
And based on these values, as they age over lifetime, they're going to have a different position and a different tangent. So that's what's driving it. Not particularly like the start position or the end position, but their age on the curve.
Got it.
So yeah, I'm just going to disable quick the force, go back into position, go back to the setup that we have here. And obviously you can increase the spawn amount. For now, I guess, do we have any questions on this particular thing?
Yeah, so we do have a few questions. So one question is from Los If Rivensky. Do you have any tips for helping to keep your graphs clean and organized? Mine is slowly evolving into chaos over time. So I guess this is a personal thing. So Kojun, what are your tips? How do you keep your graphs so
Two ways.
tidy?
You see this entire thing. So this entire section of the graph, let's just say, is adding noise, and I want to just segment this thing into its own thing. I can go into group selection. It creates a group node and says adding noise. You can rename it here, and now you can move it as a group. And there's another thing too. So let's say you have a couple of nodes that you want to reuse between graphs. You can do something that's called a subgraph. So let's just make a dummy system here, like a dummy connection of node. Let's just say a vector tree that adds other stuff and maybe put some noise here and tada. Okay, that's a section of the graph that I want to reuse in other graphs. I want to keep it clean. Well, you can select this, go on right click, and convert to subgraph operator. And now it's going to prompt you where you want to save it. We're going to create a folder called subgraphs. Go into here, give it an appropriate name, dummy subgraph, just because I'm not going to use it. And then it's going to convert it to this. So you notice that now it's suddenly so much more cleaner because it's one node. So this is how you essentially create custom nodes. And if you want to enter it, go ahead and enter subgraphs.
This is basically nodes within nodes. They're like super nodes.
Exactly.
Yeah.
And you can give them outputs, you can give them inputs. We can give them a color input, sorry. And we can give them a vector 3 output. So this would be dragging it here. And remember, once you do this, you want to save it like any other visual effects graph in order to take it into effect. Now we go back into this, and we see these input and output are appearing now. So that's one way of really organizing your visual effects graph.
Okay. You said 2 ways.
So 2 ways, sorry. Group selection and subgraph. So,
okay, got it. All right, you did the group selection there already. And when you look back at the groups that you've done, it really shows how like simple it is to just put together a spline. Like when you look at a spline in a game with the effects flying along this curve, it makes you think, man, this is extremely complex. But like actually, it's just a few nodes. You slap them together, and there you go. You have it. Yeah,
exactly. So that's really the overall idea of here, is to not overcomplicate things. This is some tools that are available to you, and just to get something that you want art directed. And then your control points, you can animate them in the timeline. You can slap a script on them, just make them move with noise, like I said. Or you can just position them in a certain way to make sort of a whirlwind. But this can easily be a hurricane. This can easily be a smoke effect or a tornado. And really, whatever is in your imagination.
And you can probably like activate and instantiate some of these with code. So if you needed to work with your gameplay, like that
exactly.
trajectory thing we saw in Dishonored.
Yeah, exactly. Yeah. So, you have GPU events here. We haven't used just because they're a bit out of the scope for the stream. But yeah, you can slap them on here, slap events through C#, and of course, drive the spawn value through code as well. So really very simple.
So, a few more questions. One from Voxel Tech. If we are using the T parameter for cube Bezier, is it linear in terms of distance, or is it the direct Bezier curve output value?
That depends. I can't really answer that because I don't know how this particular thing was built. But it seems to me that when I was playing with it, if you uniformly distribute your spheres in terms of distance, it seems very linear. Now, that's just how I interact with it. That's just what it seemed like to me. I don't know if that's the case, but yeah.
Okay. Another question, I like this one, from Evil Hitman 9999. Can you put subgraphs inside subgraphs and groups inside groups?
Let's try this out. I'm pretty sure, yes. It should be something that, if the user can imagine it, it should be able to happen. So let's just do like a float, and let's just do like a color and add some a float one with the vector 4, and let's just try right clicking it, convert to subgraph operator. Dummy 2. Yes, you can.
There you go.
There you go.
And groups within groups? Chat says you can't, but let's see.
Chat says I can't? Well, chat is wrong, I think. Because I'm in a subgraph right now, and there's another subgraph, and there is a group node that I just made with another subgraph here. So I feel that those things
can you put a group within the group?
A group within the group? Oh,
yeah, that's
another question.
Thing you can't do. Yeah.
No, I cannot do it. So now they're right. Yeah. Now they're right.
Now they're right.
Trying to make me fail. But no, it's. I don't know why we can't do it, but it should be like something that.
Wait, so if you drop it in there and move the group above, it won't move with.
No. They're perfectly right. This is not something you can do. Normally, you can drag a node like so, and just it will highlight the group node. So then it's part of it, and then it will
I see.
adjust with it. But no, I feel like there's a strict separation here.
Cool. So we're gonna have to hit up the VFX Graph team.
Yeah.
After great. So actually we wanted to do a little bit of audience participation. So if anybody has any ideas before we move on to the next section, what do you want to do to this spline? Do you want us to what kind of changes do you want us to make to it? So let us know. Throw in your suggestions. Do you want to add more, have more of them curving around each other, have them change in size at the end? You want it to go faster? Let us know what changes you want to make. Maybe change the color over the lifetime. So Fawi says add more points.
Add more points. Okay. So just let me go into all this stuff in the hierarchy. And I guess I can modify the piece in the center and go into the parameters here. You're not seeing it, but I am.
Yeah.
But we can just up that thing to like 1,000, and now it's thicker. You see, it's more dense.
Yes.
And we can also manipulate the spread here. Just make it way thicker. Now it's like
super intense, intimidating.
Yeah. It's like that licorice candy thing. I don't know what it's called, but yeah. I personally don't like to eat it, but it's here. But yeah, so that's increased to like 1,000 points spawned per second. Obviously capped at a limit that we set into VFX Graph. So that's one way. Actually, I could showcase another way that doesn't to change things, that doesn't really require that much tinkering.
Oh, Fawi says I was asking to add a few more points to the spline.
Oh, to the spline. Okay.
Yeah.
So what was the name again?
Fawi.
Fawi. Sorry, Fawi. So,
but that was cool to see. Regardless, that was adding more particles. But then,
unfortunately, Fawi, the VFX Graph team with the sample Bezier nodes only added inputs for 4 control points. I'm pretty sure that's going to change in the near future because, like you, there's a lot of feedback that the VFX Graph team took that, hey, why am I only able to add 4 control points? We should be able to have a list and have as many points as we want. Yeah, I'm with you on that one. Yeah, but for now, 4 points. I'm sorry.
I say let's change the color over the lifetime.
Color over lifetime? So that's a good setup.
Yeah.
So we just have, again, our age over lifetime. And obviously here we don't have a color parameter, but we can add one, set color.
And let us know if you can clearly see the nodes.
Yeah.
If it's not clear, we can always zoom in some more.
Yeah. So we have an age over lifetime. This is the output context. So it's an output particle mesh. And we can just drag the float into set color. It's going to be in grayscale. So bear with me. Actually, no, it's not in grayscale because of the albedo from the texture. But we can do something here. So change in the inspector. Let me just move the inspector here because I just want people to see what I'm doing.
Yeah.
And instead of changing it from override to multiply, so that becomes a multiply color node. And we can just add another multiply here to emphasize how it's changing. So now it's like very dim and it's going to go very bright at the top. But we can just emphasize it a bit more. So you see like this is changing over lifetime. But, that's just grayscale, multiplying by grayscale. We can do something more fancy, like sample gradient. So the same way we sample Bezier, we can sample gradients too. And I already have some gradients that I have here. Let's just do this, rainbow hue thing. And we can plug in the age over lifetime into the time sample here. And you notice that's
so it'll move over the gradient over its lifetime.
Exactly. So from 0 to 1, 0 being purple, 1 being white, we can multiply the color here. And now you see it's a very neonish, cyberpunkish looking foods that we have, and they're all changing over lifetime.
Yes. Oh, that looks so good.
And actually, now that we're here already,
it's like confetti. Actually,
it is like confetti. Yeah. And now they bring their color back because we're multiplying by the white value at the end, so they're actually more true to their color.
They're getting from their original textures.
Yeah.
Yeah.
And but there's another cool thing that I used a bit here to sort of modify a bunch of this stuff, and that's also using sample curves. All right. So sample curve node is the same thing as sample gradients or sample Bezier. Has a t value, 0 representing the baseline of the curve and 1 representing the end line of the curve.
Yeah.
And if you click on it, you can actually have a curve graph. So say this is like, 1 this says here 1. You can't really see it, but it says 0 to 1. You can create like some custom curves here. What's nice about it is like this is very linear at the moment, age over lifetime. Now I can do something more fancy if I want it to be non-linear and just move it to according to a custom curve. Let's say the color. I can just plug age over lifetime in the thing instead, right? And this will give me a float value, I believe, from 0 to 1. And I think we can plug into that and have it change in a different way based on the curve. So you see, like now, because it's curve,
I see,
manipulated by the curve, it's much more different. And you see,
yeah, I love that. That's fantastic. You have way more control now.
Yeah, and the same thing can be applied to, say, size.
It's not so linear is what you're doing, right?
Exactly. You want to add some, maybe a bit slow as it samples on the gradient at the beginning, and a bit...
Then speed up?
Exactly.
Oh, okay,
and cool. Same thing for size too. We use that gradient sample, but we can do it for size as well over a lifetime. And you see it's applied to the size as well. And if we just change our curve in real time, we have different things going on. So let's just put it like, increase the size at the beginning, but then drop the size at the end and then bring it back again. So we have big at the start, small in the middle, big at the end.
And that's actually really useful because you can imagine lots of like putting that into practice in many different ways, right? Like, I don't know, like a volcano exploding, it would erupt from the tip like very quickly and then slowly slow down as gravity is having its effect on it, right?
Exactly.
Yeah.
And I like the fact that you mentioned gravity or forces, because this sampling technique can be used for set position, could be used for forces,
right.
Everything, really. Because at the end of the day,
and you can apply downward forces essentially over time, right? So, or at different parts of the curve, right? So,
yeah,
okay,
exactly. So yeah, say you want, like the leaves effect I did for that project. Say I wanted to start really, really slowly and really small at the beginning, so you don't see them popping into existence, and you can manipulate the curve to start, really small, ramp up really quickly to big. And then instead of them making them pop out of existence at the end of the lifetime, you can just ramp it down so they shrink to really fast into something.
Got it. Well, I think we're good with splines then, right, Kodran? Did we cover everything?
I think we're good. Unless there's any more questions.
Keep your questions coming, definitely. I think we've answered everything so far. Actually, we do have one question from Bricolo Live. Is there going to be a way to subdivide and smooth trails for high velocity particles?
Subdivide and smooth trails for high velocity particles? I'm curious. I don't know if he means like subdividing the curve itself or the trajectory. I don't know if that's what he's meaning.
Yeah, I'm not sure, but I guess if it was subdividing the curve, you mentioned that there's like the 4-point maximum right now, right?
Yeah. Like that's the thing. It's only as granular as those 4 inputs. Now there's no subdivision operation in Visual Effects Graph yet, so you can't do dynamic mesh manipulations or curve manipulations.
Right.
But say you want to have different pacing for your particles along the curve, then for sure you can use tools like noise or sample Béziers to sort of dictate how the trajectory flows over time.
Perfect.
So there's that. Yeah.
Great. Okay, so the next thing we're going to be looking at is still be moving particles, of course, but this time with SDFs.
Yes.
So for anyone who's not aware, Kodran, what is an SDF? What does it stand for?
So this is where we start to get into more advanced stuff. Spline was an entry point, but SDF is like you're really getting into it, and it stands for Sine Distance Field. And what a Sine Distance Field is if you can imagine a cube, picture it in your head, and the cube is is made of voxels, 64 by 64 by 64, right? That's sort of like your field, right? Just picture that's your field.
Yeah.
And you have a particle, and it's going to move through that field. And what it's going to do is it's going to sample at every voxel a distance. So this is where you say Sine Distance Field. And what the distance represents, right, is the distance between that voxel and the contour of a mesh inside the field.
Yeah.
And the Sine Distance Fields, in actuality, you take a mesh, you bake it into a field, and it gives you, in the form of a 3D texture, sort of the distances between each point within that field and the silhouette of the mesh you just baked into it. Okay. And so, again, to recontextualize it, because now I'm getting into like very, very granular details, it's a way to make particles flow according to a silhouette. It's a way to make particles spawn according to a silhouette. And it's a way for particles to just behave according to the silhouette. And whatever properties you give it, or say color or size, that's it. We're going to see it applied in our sample. I built a sample to showcase. And
you can also have them react to a silhouette, right?
Exactly. There's
that's
other
kind
things
of what
well.
you did. Yeah. So we'll just put that sample up right now so you can speak to it.
Yes. Thank you.
There you go.
All right.
Very cool.
So what you see here is a car, is a cyberpunk car taken from a package. We're going to showcase it a bit, as I'm going through the sample. Mm-hmm. But it's a steampunk car, and it's colliding with the particles from Visual Effects Graph. And it is not only colliding with it on collision, it's also releasing a secondary subparticle, which are the white sparkles you see here.
Yeah.
So what I'm showcasing here is that this is the invisible field, because I baked that car into a Sine Distance Field, which is sort of this invisible field where particles are going to avoid it or be attracted to it, depending on how you mix and match the properties within the Visual Effects Graph. Yeah. And there's also another technique that I'm going to showcase. So let's say at a certain point, if the distance is below a certain threshold, you can kill the particle and make it spawn other stuff. So you can see how this thing can be used in other games, and it can be used as a weather system to avoid, say, like terrain. It could be used, say, like in Captain America, you have the shield, right? And there's bullets colliding with it, and there's sparkles coming out of the shield. So
flying over, yeah.
And you want to maintain the integrity and the shape of the shield as the particles are colliding against it. So
I think in Gears of War, there are like swarms of these flying insects, right? And you could have that, right? They were driving through that.
Yeah, so that's another cool example. I'm glad you mentioned it. It's I think the enemy is called quails, and they just flow through the environment, but they seemingly avoid all these different objects that you're like, oh wow, they seem so intelligent, but at the end of the day, it's probably a Sine Distance Field behind it that's like actually like directing these particles.
And really what this is doing is showing us how not aerodynamic this car is.
No, you don't want this car
every particle crashing into the front.
Exactly.
Yeah. Well, I mean, I'm joking about that, but you could imagine actual simulations of, putting a real car in there and seeing how aerodynamic it is by throwing these particles through, right? Visualizing it at least, right?
Yeah, visualizing aerodynamics. It could be also easily a plane, and the particles just visualizing how much they deviate or how much they bounce off, the plane. And obviously this has great benefits because in Visual Effects Graph, as opposed to Shuriken, or as opposed to a particle system that's built on top of the CPU, you can simulate millions of particles. Yes. And this is running in real time. Not only that, it's spawning subparticles too. So,
and so is this something that's feasible to put into your project in terms of something being optimized?
Absolutely.
It is.
Say you
that's
want
the power of VFX Graph, I guess.
Yes. Yeah. So that's the thing. And that's the power of Sine Distance Fields too, because what it does is that that field doesn't really communicate with the physics system in game, or the back end of the rigid bodies of every game object and all this stuff. It actually doesn't communicate with that interface at all. What it does is just, okay, we baked this mesh into sort of like a mold, and we give this mold to Visual Effects Graph, and as particles move through the mold, like sort of like molten liquid, they're gonna know where the silhouette is, where the boundaries are, and then based on that, you can inform the particles whether to get attracted to it or they could, to behave like it's, repulsed by it, so avoid it. And a good analogy to that is also like the game where, you play hide and seek, and some people say like hotter or colder. That's, at the end of the day, that field is storing a distance, and the particle goes into it, and as soon as it enters the field says, hey, at this particular voxel, is it hotter or colder? Okay.
Yeah.
Is it if it's colder, look around, check for a distance that's closer to the boundary, and it's going to go towards that distance. And that's how it is. Like, that's how it informs it. It's very efficient. What I'm trying to say at the end of the day, yeah.
And so again, I think we should look at some references. So do you have that Ghost of Tsushima blog open?
Yeah. So
on your screen? So if you open that up, and we'll share your screen, and you can walk us through that. I'll send it to you.
Yeah. Let me just get it right here.
Perfect.
Yeah. So
we'll be looking at the wind effect in Ghost of Tsushima, and we'll cut to Cauldron's screen.
Hold up a second. Just
pulling that up.
Oops. Hold up a second. I'm just trying to
Take your time. So we're gonna look at the Ghost of Tsushima effect, and then we'll also look at the BTs and Death Stranding right after that. These both are examples of SDFs in action.
Oh, I pressed the wrong key. Sorry. There you go. I was pressing.
Okay, so now we'll. Yeah. So let's cut to the screen.
Yeah. So this is a PlayStation blog article that went over the visual effects that were done in Ghost of Tsushima, and there's a lot of things in there, like the wind, the weather system, the interactive particles. I highly recommend, if you have an interest for visual effects in AAA gaming, to take a look at it. Mm-hmm. It's very insightful. But I just want to draw your attention to this particular effect. So this is sort of the wind system that sort of guides you, the player, on your quests. And what's nice about this wind system is that it's so integral to finding your next objective, where to go.
Yes.
Because you're playing as Jin Sakai, you're moving around the environment, and the wind is going to show you exactly where your next objective is. Hmm. But the particularities of this wind system is that you see they're moving in a very organic way, and that's mostly due to the fact that they can avoid things along their way. So you see there's a cliff, it moves upwards to avoid it. Same thing here. You see it's color coded. White is smooth. Red is like, okay, we're on a collision course with the rocks. We just want to get over them.
Right.
And that's what's happening. Now, their system that they have here, I'm pretty confident that, they're using some form of vector field, which is sort of the cousin from Sine Distance Field. Vector fields are, you can bake them from Sine Distance Field, but it's a field that it essentially tells the particles, hey, go in this direction to avoid it. There's some rocks, go in this direction because there's the ground here, the grass. And obviously, this is their proprietary engine. They have their own system. It might not be done with their visual effects editor, right, but the principles are exactly the same. This is what they're doing to move it in such an efficient way. Now, this is probably a collaboration with visual effects artists and programmers to get this thing rolling.
Of course. And somebody in chat did ask earlier if we could simulate a wind effect using the splines.
Yeah.
But this is a way to do that using SDFs actually.
Yeah.
So they're basically baking this terrain, right? And then as an SDF.
Exactly. So not particularly sure if it's SDF. It could be the distant cousin of, sorry, not the distant cousin, but the close cousin of SDFs, which is vector fields.
Right.
But they're so similar. I mean, in Unity, you can get vector fields from the SDFs itself because you can get a vector. But yes, this is essentially a system that in real time is baking /SDF vector fields for the particles to follow.
Got it. Cool. And then we have another example to look at, which is the BTs, right, in Death Stranding.
Yes, so that's another popular game. We can bring out the video.
Pull that one, the next B-roll.
Yeah.
There we go. Awesome. So those are them, right?
Yeah, those are them. So you can see the silhouettes. If you've ever played Death Stranding, those are called BTs. They're sort of the main antagonists in the game that hinder your traversal through the terrain. and mostly they're represented as these like silhouettes. They're never actually concrete as a mesh.
Okay.
And the silhouettes, they're represented as silhouettes with particles and an umbilical cord. And this is basically what we're seeing right now is sine distance field at play. To bake such a silhouette and have particles move and follow that silhouette, that's done through sine distance fields. And it's actually very simple to recreate this effect, at least like 60 to 70% of the way, which is what we're going to do, today as well. Obviously not going into like super big tweaking of visual fidelity, because I mean we only have a couple of hours, not weeks to make these kind of things. But
100%. So maybe we can skip to a part, just skip through the video to find the BTs, because right now,
there's
a few other things in the video. So maybe if we just skip to, I think they come somewhat towards the halfway point.
Yeah, that was the thing about like searching for these videos, is because this kind of enemy just appears and disappears. It's like,
yes. Just want to highlight them. Oh, there you go.
There you go.
And we lost him.
I think he's gonna move like just a bit forward.
Yeah, because I don't know if everybody has actually seen this. So I just want. Oh, there we go.
Okay, there we go.
So
yes.
There they are. They just pop in and they pop out.
Yeah. So yeah, they just go splash like as soon as you have the overdeck scan thing.
Yeah.
They just go into existence as soon as you're static, and then they avoid it.
Got it. Well, that's a really cool effect, actually.
Yeah, and I think that speaks to how they built it. You see a lot of particles being emitted from the silhouette of a mesh, but not the actual mesh itself.
Right.
So that's that's the technique we're going to be looking at today.
Cool. So let's dive right into it. So let's cut back to your screen, Kodran, and break it down.
Yeah. So just gonna like go into demo scene here. First thing I just want to showcase, because we're using some assets from this asset pack called the Poly Universal pack. Mm-hmm. And this is where we actually get the cyberpunk car. Sorry, not the steampunk cars out of it. I think we're using this model in particular. But yeah, very interesting one. Very easy to use out of the box. There's an airship too. And yeah, very good one. Just wanted to give a quick shout out to what this pack had to offer. But yeah, let's go.
We'll drop a link to the pack in the chat.
Yeah, we'll dive in right to the scene view here. So this is the effect we're seeing on screen, minus the subparticles. Also, the particles have been reduced a great deal. But you see, the visual effects graph actually spawns right around here. Has these particles moving with a tad bit of noise along a certain direction. So along the z-axis, and is using the SDF essentially to just avoid the car altogether. And it does a pretty good job. I mean, it runs in real time. You can scale this up to 1 million particles. We're not doing this because it's on stream, so we don't want to kind of ruin the
buffering of the stream. Yeah,
exactly. Yeah, that's a cool thing about it. And just to showcase you, diving into the VFX graph. Where is it? This is it. Yeah, just let me double click on it.
There we go.
Just to showcase you with one parameter as a preview. So now we have it being, through repulsion, but we can easily change it to make it be attracted to the car.
Oh, cool.
So now you see like the particles, they want to stick to the car.
Yeah.
They go through the silhouette. They want to stick through it, and they just flow through the hood so smoothly. And that's just driven by one parameter. I'm going to go into more detail how to go set these things up. But yeah, that's the overall scene view for it.
And you can make it repel way more, right? So if you
So now if you wanted to avoid this car is like the most toxic thing ever, you can really crush it.
There you go. You can really see, especially if you go behind, you can really tell. It's
really
it's avoiding it. Yeah,
it's really avoiding it right now.
That's so cool. And these are just basic particles, right? So the main graph is just like there's nothing like they're just normal particles, right? And
Yes.
then you're just spawning them on one axis,
Exactly.
and then building. You're creating the SDF from this mesh in Unity.
In Unity. So I'm gonna go over how to how to do this. Just want to showcase one other thing. So
Yeah.
Obviously the graph is very simple. Not too much going on in the setup. And there's also another feature that you probably saw in the preview video, which is, okay, on collision, or it's going to create these new particles, these white things. And obviously I can just remove this thing, the cube, so you can see it much better. And now these are invisible particles, but as soon as they collide, they produce these small particles here.
Cool.
And yeah, that's sort of the three things we're going to go over through this graph.
And if you have any questions as we go along, please just drop them in the chat, and I'll be taking the questions as Kodrin is showcasing the tool.
Now, this is all cool, but now the question is like, okay, how do I do this? How do I bake this? Because as we saw, an SDF is a 3D texture, and we're going to need to get that 3D texture somehow. And
so when you say 3D texture, usually when people think textures, they think 2D.
They think
right?
2D, yeah.
So what do you mean when you say 3D texture?
So if you can imagine, my phone is like a texture, right? Now it's 2D. There's the X and Y, and each pixel, it's more wide. So imagine this is like a 1920 by 1080 2D texture.
Yeah.
Now, a 3D texture, what essentially does is it takes this, and on the Z-axis is going to have multiple cell phones.
Right.
So that's going to thing. And say it has 10 cell phones. So it's a 3D texture that you can sample even in the Z direction.
Okay.
So that's pretty much how the best way I could explain it.
So is it essentially taking that mesh of this car, slicing it up into these 2D planes, and then you're pulling from that data?
Exactly.
Okay.
And it's going to be more obvious, and I like the way you explain it as well. Like it's through slicing. Yeah, you can take a cross section of that 3D texture and you can sample it, and that's totally doable. So yeah, but any questions so far? Like,
not yet.
All right, so we can just dive in how to create like an SDF. So if you've been there for the first episode, you remember that we went to look at point caches. Now, is this in the same place where the point cache baking tool is? So you go into Window, you go into Visual Effects, you go into Utilities, and you got the point cache bake tool and SDF bake tool. Now, this is very new, and this is courtesy of the Visual Effects Graph team. They did a great job on this tool because it works so beautifully. And now, let's just say we want to bake our car here. What you want to do, you're going to be presented with this interface, and you're going to need to have a mesh inside of it. And we need to like properly select the mesh of this car. So let's just go see where this thing takes us. Let's just put the inspector here. We can see that the sport car has a mesh, and this is the mesh that we see here. Let's just double check it. Yeah, that's the overall hull of the mesh. So that's a pretty valid mesh to start baking it.
Perfect.
You can slap it in. Now, this is what you get when you slap in a mesh. You're going to get some live preview here, showing you the mesh that you want to bake. And there's a nice little button here that's called Live Update, which is going to show you what the 3D texture is going to look like. All right, so this is your 3D texture. Now it can be displayed as a volume, like you see here.
Yes.
And you reduce the alpha, so you can see inside of it, but it's not really that visible. You can also put it like a slice, like you said, Hassan. And you see the dark spots are where it was baking it at the cross section. And if I move the slice, it's gonna display like the hull of it. But at the end of the day, like I said, it's just a grayscale value map that's being baked in. And you can actually click on SDF. So this is being shaded in 3D. And you can see here, this is...
Can you bring that to the center of the screen?
Yeah,
possible?
sure.
Just, yeah, it's being covered by a few of the stream elements right now.
Yeah. Is it better like this?
Yes, much better.
Okay. So now you can actually see the hull of it. And this is what Visual Effects Graph is going to be reading. It's this Sine Distance Field. And you see it's a texture, 28 by 22 by 64. And now you can increase the resolution of this texture by just changing this parameter here. And what you're going to notice is if we go zoom in a bit deeper, if I change it to like something like as a low resolution, you see it's kind of very decrepit looking. It's not really refined. So a good resolution for these kind of things I like to put 128. 128 gives you a nice in between.
Okay.
And it's pretty smooth. And as soon as you got that, now you're like, okay, I'm ready to bake.
Yeah.
I just put save SDF. You're gonna go into your folders. You have my SDFs, and I'm gonna put on stream car. All right, that's my SDF. I'm just gonna bake it as a Unity asset. Now, if you go check it out in the project settings, on stream car, you're gonna notice that it's now baked as a dot asset, and it is basically giving us the same information that we had previously in the SDF Baker to like sort of display this 2D texture. It also gives you the resolution. So it tells me that it's 56 by 44 by 128, successfully baked at 128 max resolution, and now it's ready to use.
So we have a good question from Killing Dracula 79. Yeah. This might be an obvious question, but can VFX Graph be affected with this method by moving objects? So I think they're asking, say you were to move this car in real time, since the SDF is on this car right now and the particles are being affected by it, can you actually move it and watch the particles reacting to a moving SDF in real time?
Yeah. Yes, but there's some setup you need to do. So you're going to notice that once we plug in the SDF inside of the VFX Graph, we're going to need to match that with the silhouette of the actual mesh of the car.
Okay.
Now, as soon as you match that, you can plug in the position of the car, plug it into VFX Graph, and then as soon as you move the car, it's going to be, okay, now the particles are going to know where the car is and match that SDF with the car, and then, okay, just interact with it where the car actually is.
Great.
So yeah, very good question. Thank you for that.
Yeah.
I guess we can go now and go into the graph.
Yeah.
Showcase it. So we have the SDF bake tool. We're just going to put it here, stash it in here. We're not going to use it that much anymore. And I guess we can go into this visual effects graph. So, all right.
So now we have our SDF.
Exactly. We baked it. It's successfully baked. Now we can do some cool stuff with it.
Cool.
Now, like anything in particular, like last time we worked out of these 4 contexts. Don't worry about this yet. This is just like the sub particle emission. But yeah, we're just gonna look at some of the nodes that are offered to us for displaying it. And let me just also quickly disable that. Oh no, sorry. Disable the car, not the effects. All right, cool. So now we have the effects without the car. And there's a couple of nodes that Visual Effects Graph and the VFX Graph team are giving you. One is within the context itself called Position Sine Distance Field. And the other one is in Sample Sine Distance Field, like we saw, Sample Bezier, Sample Curves, and all that stuff. But for now, we're just going to disable a lot of the stuff that's happening in Update, just so we can just showcase the block of it. And we're going to spawn. This is the spawning that happens on the left side. But let's just use this type of spawning position. Actually, let me make it move a bit with some turbulence, so it actually displays.
Wow.
Yeah. And let me just reduce the amount of turbulence so it really spawns on the silhouette. So
that's so cool. That's so cool. Yeah.
Thank you.
So now you can actually see the silhouette of the steampunk car.
Exactly. And actually, let me just re-enable the drag so it sticks more to it. But yeah, so the first node that's available to you is the set position node that says Sine Distance Field. And this one is available for you in the initialized context. So what I'm essentially doing here, you remember how I used that 3D texture? What you essentially have to do is just plug it into Visual FX Graph. In this case, I plugged it in through the inspector and hook it up to this node, this block. And then you're going to get some options that are available to you. So the position mode, you can make it spawn on the very surface, or you can make it spawn in the volume itself, inside of it, that is. You see, if we go inside the silhouette of a car, it spawns inside of it. But if I go into the surface, only on the outer shell of it. Now, obviously, there's more things they're seeping into. Yeah. You can have it random or custom. I haven't really played that much with the custom one, but that's just like gives you this weird arch parameter that allows you to just rotate along its hull. But I'll just keep it at random because it's simpler. And there's the second one, which is the field transform. Now, this is a very important one because know how you can actually position things in 3D space through these 3 gizmos like XYZ. This is called your transform component in Unity. I'm pretty sure a lot of you are already familiar with that, but it has a position, the rotation, and scale. Well, an SDF inside of VFX Graph also has these parameters. And it's important to play with them, especially the size, to sort of get the dimensions right and proportional to the texture. And this is like the person asked, how do you get things to match with moving objects? This is where you could do it. This is where you could put the position of the moving objects and align them in a certain way and align them dynamically and in real time. So that's the first part of it, right? And you notice here I have some stuff going in here, but with a transform. But yeah, so first part, that's what you get, the silhouette. Nothing really amazing going on. And by the way, I just want to give credit to Keijiro Takahashi for this portion of the graph, which is just the coloring. I just liked the way he colored this particle, so I used it.
Oh, cool.
But so we have this. Now we're going to go back into the hierarchy. Now you have the effect here. We've selected it. And let's just put this here. So now I expose the 3D texture, the SDF, as a property. So you can obviously assign a 3D texture here. You see car no hoods. This is the texture we have here. And it's looking nice. Now, obviously, if you input it into Unity just like that out of the blue without anything, let me just show you. I'm just going to delete that custom transform we had. Let me just show you what happens. And so you guys can understand it more. This is what's going to happen. You're going to get like a bunched up cube and you're going to be like, this is not my SDF. There's no silhouette here.
Right.
This is like, a 1 out of 10 experience. Like, this didn't do anything. You're frustrated. You're like, I don't want to use this again. Look, my car is squashed. This is where the seat is. Why is the thing so like bunched up?
Right.
And this is because we didn't proportionally scale our SDF according to the texture. Now remember, your texture is not uniform. It is 56 by 44 by 128.
Oh, that's right.
So we're going to need to respect these proportions. So there's a bit of tinkering around, but at the end of the day, I made a parameter that's called texture resolution, where you input the texture resolution, the scaling, and you put it into a transform node, which is going to automatically handle the scaling for you inside of Visual FX Graph. So
and this is something you're going to have to do each time, right?
Yeah. So, as soon as you have this setup done the first time, you can reuse it and you don't have to worry about it anymore. So we're just going to plug it back in. And like I mentioned, now it should be working fine. Now it's scaled properly. It's not squished on the Z axis. And nice thing about that is, like I said, you put the texture resolution here. This is the car no hood, so 105, 79, 249. This is the exact parameters we have here. And obviously I put some scaling parameters, so that's just a flow value. And this is just to like, okay, I want to match it up more precisely to the car, right? And it gives you sort of this universal value to uniformly scale it. So I can just put it even more higher, like 100, and it will just be very small. Yes. Yeah, so you see. But I already lined it up. So this is your job to just line up the SDF with the car itself. So for me, the value 12 works really fine. You can put back the car and you see.
You're just eyeballing that, right? Like just the scale.
I'm eyeballing it, yeah. Obviously, in a game, in a production, you would have a system for doing this thing. You would have a pipeline. Because eyeballing things all the time, although it works for now because we're just showcasing some examples, when you're in production, you want to have a pipeline for it. Otherwise, if something were to change across the pipeline, you don't want to have to do all this stuff manually. So, you maybe could ask your developers, hey, can you have like a tool that aligns this thing for me automatically? And be like, yeah, sure.
So I don't have to worry about it or think about it.
Yeah, exactly.
But if you're doing this in your game, like in just one or two places, and you're a smaller team, then I could imagine just eyeballing it and lining it up to make it work.
Absolutely. If I'm like, there's one particular effect or 2-3 effects that I'm using SDFs, and I'm like, that's not really that's such a big part of the game, but I'm using it for a cutscene. Then yeah, eyeball it, no problem with it. Whatever allows you to go from point A to Z. But if you work on a production like Death Stranding, and you have a lot of things that use SDFs, then you better have some pipeline or some way to automate this, because you don't want to have all your artists wasting a lot of their time just plugging things manually, essentially. But yeah, so that's the first way to sort of get your SDFs on screen. Now, this is just to set the initial position. Now you're wondering, well, Kodran, I want to make them like avoid this car, or I want to make them be attracted to this car, or do all the stuff that I showed you on screen. Right. So there's this. Let's just put back to the little setup we had. Let's just make the particles spawn on the left side of the car, and let's make them move towards the car. So I have a simple gravity node here. Put it -23 just to make them move towards the car, and you see it doesn't do anything. The SDF right now it's just meh.
Yes. It's just flying right through.
It's flying right through. So let's look at this. So this is the sample Sine Distance Field node. Get it from outside the graph. I'm going to look at it. This takes in a texture, which is your Sine Distance Field. This takes in your oriented box, which is the same thing we put into at the beginning, which is your proportional scaling. And we're obviously going to use the same one for this one. And there is your position. So that's your local particle position. Obviously, you're traversing a Sine Distance Field. So you're going to need to get the particle position at the particular point in the field itself. Right. And then there's another parameter which I don't really use. It's not something that you want to worry about, but it's if you're familiar with maps on textures, there's that available for you. But in this case, we're just not using it since it's not really useful for now. And what it outputs, obviously, is the distance. So the distance from that current position to the boundaries and the contour of the mesh. And it also outputs a direction. So it can give you distance, but it can also give you direction. So instead of saying hot or cold, if you're closer, it can also just outright point you as like, this is the direction you need to be following for the particles to hit the boundary. And even though it says Sine Distance Field here, this is what allows it to become sort of a vector field too. So this is why I say like they're really close cousins. And yeah, but for this example, we only need the distance, so we're going to use that. Perfect. Now, I connected the transform already into the oriented box. I connected the Sine Distance Field already into the texture. I connected the position into the position. I took that. I'm going to explain this in a little bit, but this is all set up. And we're going to take a look at another thing, another node called the conform to Sine Distance Field. And this is something you use in your update particles. And you notice it has the same field transform, the same Sine Distance Field, but you notice that there's other parameters now. It's like attraction speed, attraction force, stick distance, stick force. And this is like out of the box, like VFX Graph team came up with this block, and I feel it's so beautifully abstracted for the user to just create these kind of behaviors. Right. So obviously I'm just gonna take this and delete it. you see I have an attraction force of 24. These are arbitrary values, obviously, but you see how it behaves. It behaves almost like a waterfall effect.
Right. It's just like because you turn the attraction up, right? Here?
Yeah, exactly. And obviously I can make it into the negative 25, and it'll just
here we're
avoid
really
it.
seeing how the scale is kind of off.
Yeah.
Because it's attracting to the inside of the car. So if you were to just scale it up a bit, you would really see it like riding the surface.
Yeah. So like 100 is like, oh my God, it's really going to stick it now. You know, this is like a swarm of like insects just wanted to get into the car. Or you can just do something that's more smooth, like sort of water. A good use case for SDFs also is water, is a waterfall. If you have a simple waterfall scene and you want some particles just flowing through a silhouette, that's good too.
Right. Like falling down the edge of a cliff or something. And
exactly. And yeah, this is the stuff you play with. I mean, obviously, up to this question how you play with them, but they're very simple parameters. Mostly, I just use attraction speed and attraction force.
Yeah.
And yeah, like now we're ready to revisit some of the stuff. So you notice that was plugged into attraction force. So attraction force was plugged into our sample distance, Sine distance field. And what I was doing here essentially, so I was doing a more fancy setup to get more interesting results, and you can clearly see it here. So what I did was like I took the distance output, clamped it, which means limited between 0 and 2.36. Not going to go too much into the math, but divide it, and that gives you a scale from 0 to 1. And this scale of 0 to 1 tells you the particle how much. It tells the particle like how much influence it should get from the SDFs at a particular distance. So you notice now my distance is of 2.36. So if I increase the distance, it's going to get more of an influence.
I see.
So it's still using the shape of the SDF, but I can scale it down so it's less of an influence. This is some way to add more control to the Sine distance field.
Got it.
So that's what all this section does. And obviously,
a multiplier on the values that you're changing within that node at the end, right?
Thank you. Yes, exactly. You said it beautifully. A multiplier. And what this multiplier does is that it gives you a value from 0 to 1. And values from 0 to 1 are such beautiful values because you can scale them after, or you can do all kinds of fancy stuff. And this is what I'm doing. Remember we visited sample curves where we just put a value from 0 to 1 in the time and make it behave according to a curve. So this is exactly what I did here. I'm like, okay, at the beginning of the sphere of influence, I don't want it to behave as much, but I want it to quickly ramp up. And you can clearly see it here as well. Like, let me just move it around. It seems to show it as much. Probably because I didn't plug it into the color. Sorry. Let me just plug it into the color for you. So yeah, very not much at the beginning, but I can scale it up so you can see like, oh, there's much more at the beginning happening right now. Not much. And this is, like I said, curves are a great way to just, not make things linear, but make things a bit more organic in a way.
Absolutely.
Now, you're going to notice as well that I mean, this is all plugged into the color. Let's go back to our normal color. But I use these things, this setup, to plug it into the attraction force. So this kind of like non-linear trajectory with the sample curve multiplied by the repulsion, like -15, is used for the attraction force. And this is how I'm using the Sine distance field here, like plugged in. And it's a combination of the two. So you notice this one is using the Sine distance field, but I'm using another one here just to get more organic shapes out of them as soon as the particles enter the field. So it's not just always linear.
Tesla RX in chat says this is a B armor.
B armor, yeah.
That's actually a very cool use for this. Could you imagine just like organic?
Oh my god!
As armor.
My mail from LinkedIn. Holy that. But yeah, so yeah, like there's a bunch of stuff, that you could do here for like you said, armor wise, like bullet trajectory, waves, sort of like wind effects and airflows as well. This is what you're seeing here. And yeah, it's a combination of two. But there's also a third thing that we didn't see, and this is equally as simple. So you see how you get a grayscale value between 0 and 1, again here.
Yeah.
Now you can say, well, listen, I want to sort of compare that grayscale value, and if it's anything below 0.1, do something. So this is why I'm using a step node. The step node is essentially a fancy if a simple if statement that says if this value is smaller than the threshold, output 0 or 1. And now I put it here. So if this is equal to 0, set particle to be alive or dead. So in this case, oh, you see my particles disappearing. So they die when they collide with it. Now, I could do the same thing and be like, hey, this thing outputs 0 and 1, and then I can multiply by 100 and say, well, as soon as it collides with that threshold, I can spawn some more particles underneath it. So this is what I'm doing here. And let me just disable the color so you can see it in full color. And this is what it does.
Oh, this is awesome.
Yeah, and this is the basic setup for the subparticles. I'm not going to go really too much into detail because I mean it's a simple setup, but you know, a bit of turbulence here and there.
I think just in the essence of time, since I think we've got a good idea of how SDFs work, we now know how splines work as well. So we can actually do what we promised, which is to build some BTs.
Yes.
We recreate the BTs that we saw in Death Stranding. So thank you for showing us this, Kodran. This is absolutely amazing.
Thank you.
And again, something that looks incredibly complex. You've simplified it down for us, so I appreciate that. And for myself, I'm gonna go mess around with this shortly after the stream. So I think let's look at the actual footage of what you've made. And we'll look at that, and then we'll actually make it.
Yeah.
So you can quickly see here, those are the BTs. You saw them right there on the right, and here they're hovering, basically kind of anamorphic bodies made out of particles, anthropomorphic, sorry.
Yeah.
With these little umbilical cords coming out of them, and I think you have it on your screen, right? So when you have that up on your screen, we'll cut right to it.
Mm-hmm. Yes. So that's another thing here. So you notice how the particles I just removed it with a silhouette. This is a basic BT setup that I have for you guys.
Amazing.
So this is the particle effects, just like maybe 60 to 70% of the way there. But there's some characteristics of how the BTs move, which is it's pulsating, and the particles sort of like go from like randomness, turbulence, and then they morph back into shape, and then they go do that again repeatedly. And not only that,
there's incredibly accurate to what we just saw in the video, because I noticed that as they're moving, it's not just forming the shape, but there's that you can see the little explosions almost of particles happening at different parts of the body. Yeah.
I mean, obviously you got the umbilical cord, which is spline driven, so got your case up here. And not only that, when you play Death Stranding, you know that the BTs, they have this thing where the particles shift from one direction and on one pulse, and they shift to the other direction another pulse. So we're going to look in how we achieve that as well. And this is really a combination of what I've been showcasing here to just build, you know, one of the iconic effects from a really great video game.
And how, like I said, you think we can get that done in about 10 minutes?
Yeah, I think we can get that done in about 10 minutes.
Let's do it.
Should be fine. Yeah. So first thing, I'm going to deactivate it, but you see the BT cord. So really, I like to reuse a lot of my graphs, and I encourage you to do the same. I basically reuse the same behavior from the food storm that you saw there, and this is what you're seeing here. Same setup. I just outputted the particles cubes. Didn't put much effort into making it, you know, look physically like super accurate. Yeah. But I'm just trying to showcase the motion. How do you do it? Absolutely. Like I said, okay.
And you can replace these particles with anything. As you saw, it can be what you're having for breakfast, as
like a breakfast BT. Yeah.
You know what? Let's make one. Let's make it a breakfast BT. Yeah.
But yeah, like, you know, it's basically here. You can add some turbulence here if you want, just to really accentuate some more of the intensity, the frequency. But just to add some more variations here. Actually, I think I should probably add it through that noise over there. Probably increase the frequency and increase the amplitude. Maybe decrease the frequency. Anyways, a bit of a bigger chord here. And obviously, now we're going to the main thing. That's good enough. I mean, if you want to play and add more variations, I'm going to show you later on with the body how you add the same variations to the chord.
Yeah.
But in the interest of time, just move forward. There's the BT body. But first, like we said, we always need to bake something because we need to have a model. And I found some model off the internet. So this is Mixamo. It was a really weird idle pose from a mannequin. And I just basically snagged that off the Mixamo. It works well enough for our purposes.
Perfect.
And like we said,
Mixamo if you're looking for default like animations that you can use in your project or meshes.
So when you click on your VFX graph, you can have pre-warm time and all this stuff. So you just increase these timers, and this will just pre-bake the start of it. So it doesn't have to you don't have to wait for it to just emerge out of nothing. You can just have it appear as soon as you want it. And obviously you can pre-warming is one way, but you can also do it through the graph itself. So instead of using constant spawn rates, like I want to spawn say, oops, wrong graph again, BT body. Instead of doing constant spawn rate, let's just do a single burst and put like 20,000.
Do big numbers in the VFX graph.
Yeah. So you see, like I press save and boom, just spawn.
Yeah.
Starts. Yeah. So that's single burst is one of the ones. If not, I mean, I want it to emerge slowly over time, so I put a constant spawn rate that's a bit lower. But these are two ways. So very good question. Yeah,
that's great.
And let me just put these things back. So we're at baking our little boy here.
There we go.
So
make sure you're not an live update.
Yeah. What you see here is the SDF for him. So you see he's a bit jaggedy. So we're just gonna raise up the resolution to 128, and that should fix him. See. He's 50, 128, and 82. We can bake him.
Chunky in there.
And put a BT asset on
so
stream.
Are SDFs also mobile friendly? Some people are asking. They asked about splines, and we said test it out. So would you say the same thing?
So for these, they're mobile friendly because at the end of the day, they're just a 3D texture stored as a dot asset. So there shouldn't be any problem using it in C# as well. Or I still don't know about VFX Graph because I'm not really a mobile developer. But like I always say, just try it out, test it, port it to mobile, and see if it works. So I'm gonna run you through this. We're going to build it from here. So I'm going to have this same setup. I mean, actually, we're going to build it out. It's really the same setup that we used for the Sine Distance Field. I just copy pasted that, but I'm just going to break it down one by one.
Right.
And yeah. So
why is there just a single wisp coming out right now?
So now we don't have anything in it. Right now it's spawning from 0, 0, 0. And it's also spawning from a sine wave here, like the variety. But let's just put it like a solid spawn, like 1,000. And it's also because we have some gravity being shifted around. So that's a leftover. But really, that's what we start with. a lot of particles into one singular point, which is not what we want. So, like I mentioned, we're going to use a lot of the tools we looked at. First and foremost, the position one. So, really, plug in your SDFs. Make sure they're properly scaled by, like I said, going into the texture resolution. Plug in the BT. And luckily, we're not using a mesh, so we don't need to like fit it to a mesh or match it. But this is what we have here. The position block nodes. Obviously, we use the same logic for transforming it. Texture resolution, divide by some scaling, put into transform node. And every time we're using this SDF, we're going to use that to transform. We're spawning out on the surface in a random way. We want our particles to have a relatively short lifetime, so I put it 1 to 3 seconds. And at the beginning, you can put some initial velocity if you want, like this one. So that's optional, completely optional. I probably best not to put it, but I put it just because whenever you spawn a particle, you also need to assign it a velocity in order to make it appear. So if your particles are not appearing and you just only have your position and sine distance field, that's because you need to make it move somehow. So either through velocity or gravity. But we're just going to put some really low value and put everything back at 0, 0 so we can display it. And that's pretty much it. So now our silhouette of the dude is displaying.
Yes.
Now obviously we want to make it conform and move to the silhouette. That's our second step. So we can go use our conform to sine distance field, which is right now it's being attracted to the silhouette. And you notice that there's not much difference, but you see the particles are jittering, but they're jittering because there's no opposing force. They're just a very linear force towards the SDF. So a great way to just nullify that is use turbulence, honestly. Like it's, now it's like conforming to the SDF and moving in an organic fashion through noise.
Nice.
You can change the intensity, see here. And now we essentially established the default state of our silhouette. So there's that. We also added linear drag to control a bit more universally, like how fast the particles are moving. So you can see, like put it down to almost 0, moves very fast. If I put it down to 4, it's a bit more control. It's just, I like to have control. That's it.
Absolutely. And so now, what it's missing now is that pulsating, right?
Yeah. So you see, like the SDF right now is very static. It's just a guy chilling. It's not doing anything. It's very boring.
Yeah.
But right now we need to focus a bit on some movement that's just like like you said, pulsating. And one of our chat viewers specified sine waves, which is actually very smart. Every time you want to make something undulate or pulsate, like it intermittently over a period of time, sine waves are always your friend. All right. Yeah. And this is so much stuff can be rendered organic through sine waves. It's just incredible. Noise and sine waves, which was also part of the first VFX live stream. I went over it. But yeah, so we have a sine wave node in VFX Graph, and what we essentially want to determine, what we essentially want to change first is the amount of particles, because it goes from low intensity and then pulsates to a lot of particles, and then goes back into low intensity, does the same thing. So we want to drive that with the sine wave itself. And the way we do that, you put the time, so it samples over time and just undulates. It's not static. You just plug that into the input. It's very standard. Change the frequency so it's a bit lower, and this is the min-max value, so it's only going to give you an output of between 0 and 1. Now we can use that towards a linear lerp function. So this is the S is like the T, but 0 being 1,000 particles and Y being 3,000 particles. And then I also plugged it into like a multiplier, so in case I want to change it some more. But here's the effect of this. It pulsates, then it reduces the amount of particles. It pulsates, then it reduces the amount of particles. Now, it's not really visible, so I'm going to make it more visible by adding the gradient with that pulsation, so you guys can actually see it. Um, is what it's doing, right? So blue, it's calming down. It's not spawning as much. Red, it's spawning more. And actually, let me reduce the lifetime.
And this is good practice, I think, in general, to like debug what you're doing in a visual way, right? So like throwing something into the albedo first, you know, so you can actually see it. Or for example, you do that with shader graph often, where I'll link things to the albedo, visualize it, and then put it where it needs to be. Something that's like very visually like evident.
Absolutely, and I'm really glad you said that, because you obviously don't have a debug view in VFX Graph, and color is one of your best ways. Color, size, positions are some of your best ways to just debug what's going on.
Yeah.
And sometimes when I'm not sure, is it actually behaving? Well, you just plug it in. It's like, oh yeah, it's actually behaving the way I wanted it to.
Right.
So now you see, sine wave is dictating how many particles are being spawned, how many how many particles are being spawned. That's what I want to say. And it's doing that in a very intermittent way because of the sine wave. Now, obviously, I can increase the frequency, but it's not going to look very organic, and it's not going to have much of an effect over a spawn rate if it's too fast. So I'm just going to keep it at 0.1 or something like that. Maybe 0.18 or something. Much better. So we have that. It's spawning. Oh my God. Yeah, sorry. Sorry about all the notification. Yeah. So now our next focus should be sort of like shifting the particles outwards through noise and then shifting them back to the silhouette. Yeah. And we can use the same sine function to do that. So you notice that we have that force that's like sticking up and here and there. And we also have the turbulence to sort of do that kind of stuff. So you remember, if I just change the turbulence, it's more random. Yeah. It deviates from its original shape. So obviously what we want to change here is the intensity. So we just take that same sine wave that's between 0 and 1,
apply to that noise.
Okay. Interpolate it between values that are more suitable for that intensity, which is between 1 and 4.
Great.
And you just put it. So now we got, okay, cool. It's moving and readjusting to its shape. It's moving and readjusting its shape. So you see, now it's like ping-ponging back.
Yeah.
Right? Back and forth. So now it's like, it's still looking pretty static. The whole body is just like sitting there, suspended in the air. Kind of want to make it move a bit, And this we're going to achieve through the gravity node. So we're going to uniformly affect the gravity of the particles.
Okay.
Because the BTs, when you see them in game, they're not just behaving, they're supernatural beings. They're from another world. And they're not behaving according to the rules that the protagonist is in. Yes. They're actually just more ethereal, mystical, ghosts. And you can see that, it's not really sure. They're just floating in a way. It almost seems like there's some gravity here, but not really. So we can do that. I just decided to use a three-dimensional Perlin noise, put some time in it so it moves and samples different values over time.
Okay.
And use a three-dimensional vector here, scale it up to a multiply. And that's essentially the thing we're going to apply into our gravity. Now, obviously, you see, if I put an arbitrary number like minus 50
on that axis. Okay.
Yeah. So we're just going to pull that and randomize that a bit. So now you see, we're getting the impression that it's floating a bit more now. Yeah. And we can actually accentuate that with the multiplier. So that's really as simple as it gets.
And you can even feed this through the sine wave too, right? You could have that be pulsing, that gravity effect be pulsing.
Yeah, that's exactly it. So we can feed also put multiply and affect the gravity on and off kind of deal. Right. So we can have the sine wave that's just being plugged into here. Yeah, that's it. So it goes back to very static at the end of it.
Yeah.
And you see there's no like subtle movements anymore. They're just like, okay, very stiff to very organic.
So now you can really see it. And can you displace the two sine waves so that they're not both happening at the exact same time, the way they are right now?
Absolutely. So, where now we have our sine wave just like behaving to a time value, but we can take the same time just add some value to it, like, I don't know, whatever. Put it as an input, maybe change the frequency, and have it happen on different tempos. So let's just put this. Oh wait, let's set to the X, but let's just make this one drive the intensity of the turbulence. And you're gonna see there are different tempos now.
Oh, that's very cool.
Yeah, so it's a bit of a more of an asynchronous thing. So, you know, really good suggestion there. I mean, like, you know, you can change the tempos by changing the input of the sine waves themselves.
That's just experimentation, right? You can have fun with it. You can, you know, if you were to. And is this also going to be up on the repository that you were talking about?
Yes. So you're going to get this. Obviously, it's not using assets from the asset store. Everything you're going to see on here is going to be available, but just as cubes.
Perfect. So you can access this directly, and then you can make your own changes, have fun with it, learn by reverse engineering it. Let's look at this in full screen. Can we look at this? Do we have a camera set up on this already, or
let's see.
Or we can just look at it in scene view too.
Yeah.
There you go. There's your BT, as promised.
As promised.
As promised. Wait, so are we able to change the mesh to that breakfast pack we had earlier, the food pack?
I think we can. Yeah. Let's actually let's try this doing this actually. So we have to go into the scene. Let's see. Mega food pack. A bit disorganized here, but let's go into this one. So there's a lot of things we can choose from.
Let's choose the eggs.
The eggs. Okay, the eggs. What kind of eggs? Do you want like the soft boiled eggs, or do you want the flat eggs?
Flat eggs.
Flat eggs. Okay.
Soft boiled eggs. Who do you think I am?
Oh man. Yeah, I like soft boiled eggs. It's good with ramen.
That's true. I do like soft boiled eggs with ramen. I'll give you that.
So yeah, let's just take our SDF baker. I can't believe I'm baking an egg. But here it is.
No,
man.
but can the egg replace the particles? Is what I'm saying, right?
Oh, you want to replace the particles with eggs?
Yeah.
Oh man, what did you say? Yeah.
Sorry, yeah. I was like, don't need to make a floating egg BT.
Don't worry about it. It's all good.
Yeah, that's a lot simpler, I think.
Yeah. So what you want to do is duplicate, but you can also duplicate with edges. So what this does is that it duplicates the same output, but it maintains the connections. Obviously, we want to stop that, and we want to convert this to particle mesh. This is what we have here. Now, excuse me, I'm just gonna like find the egg and plug it in.
Okay.
You're just so excited for this.
I'm so excited.
Now, obviously, they're really small, so
It's so absurd.
it's so absurd. And we obviously need to change the thing here, and obviously we need to just not make it appear as the color.
But I mean, it's just cool to see how quickly we changed everything.
Yes.
Yeah, so it went from a BT to a breakfast BLT or something.
I'm not sure I used the correct texture, but you got eggs for your BT.
Yeah. Beach thing to breakfast time.
Let me find the actual good texture for it. So it's in the follow along because it was in this thing here. Okay, let me just go back to that
You're
screen.
right. Chat says this looks like cells. It kind of does.
Yeah, it does.
That's
pretty creepy.
actually way more creepy than I thought it would be.
It's nightmare fuel, man. Yeah. But yeah, so I'm getting the good one. Color pizza palette. So the color is good for the texture, but I'm sure that there's some other color that's being manipulated here that that's not making it
Like
look.
some live debugging right now. Live debugging.
Oh no, I just had the UV wrong. Sorry.
Okay, there you go. There you go. It's now
There
a
you
BT made of eggs. This is Hideo Kojima's breakfast dream.
Yeah. And it's shifting with X.
Somebody at Hideo Kojima, please. Okay, so that's your stream for the day, everybody. Thank you so much for joining us for the second episode of the Let's Dev VFX Graph series. Hold on, I'll wait for the two cam to pop up. There we go. Hello.
Hello again.
Hello again. Thank you so much, Kodran. This was amazing. If you're not already following us on Twitch, make sure to follow us. We're doing streams like this every Wednesday. We're interviewing creators. We're doing Let's Devs, looking at 3D